Today we will discuss the PMI LLP 1500. This specific model goes up to 500 psi, which allows you to get down to 4 nanometers in pore size. This specific machine is designed to take two immiscible liquids and use this interfacial tension between those two liquids to calculate pore size distribution, the pore sizes that the smallest pore size available, and also to give you an idea of the flow through your sample. So, today what we're going to show you is just how to set up the sample for easy use and for future reference in case you ever have to show someone else. This machine has a few key components. So first we have an insert that is about 1.5 inch. The primary purpose for this is to give height in here so that the piston doesn't have to come down as far. The piston is designed to go all the way down if necessary, but by having an insert in there, it can make the test go a little smoother and the piston doesn't have as far travel. This is the first layer which goes into the chamber like so. Next, we have a flat membrane plate that has multiple different holes in it. These holes are designed for the flow of the liquid through it. However, because of the large size hole, a lot of samples going up to 500 are very fragile and delicate. What we have to protect them is a millipore screen that has much smaller hole diameter. This goes over the screen and adds an extra layer of protection. So it adds an extra layer of protection for the membrane so that you don't puncture it before it's time. So a flat membrane type sample is placed onto the screen. You want to make sure that you get the screen fully covered with the sample. This way you have no gaps there and no easy way for the liquid to travel. After you have placed this, after you have placed the membrane on the screen, you have to put a gasket on top of it. The gasket allows for you to seal around the sample, locking it in on its location on the plate, so that the liquid can only go through your samples, not around it. Once you have that set up, you place it into the chamber and you put another plate on top of it. Normally you put a plate on it that has a smaller hole diameter than what the sample is. This way the liquid will go straight onto the sample rather than get stuck on the gasket around it or anything like that. You place this on top and you close the chamber. Now I will quickly go over the different parameters that are used with the specific test, and then you'll see this test start. You will not see the graphs today. You will not see the entire progression of the test because these kinds of tests can take anywhere between 15 minutes to 3 hours. It all depends on the parameters you're running them at, how high of a pressure you're running it to, and how many data points you want. So this is the liquid software that we use to run the test. I'll first show you a picture of the manual control. So the manual control screen shows the different valves that are associated with this machine and the specific order by which the things flow. Here we also have different pressure readings based off of the pressure gauges you have in your machine. You can do a lot of the testing you want in the manual control screen, however this is just a good reference to make sure that everything is reading correctly and that valves are firing as they should. The other key thing you have on here is the balance. So this is giving your reading for whatever the balance is currently at. This is a critical thing when running the test, because if the balance is too full, the test won't run. So, the auto test screen. We'll hide that for now. What was it? So, With this specific screen, you input the sample name you have. At your company, whoever is operating the specific machine, so you always have the reference there. A specific lot number or identification number you want associated with those samples. Then, if you're looking for Darcy permeability also with the membrane, it is important to put in the known sample diameter and thickness that your sample is being covered. If you're not concerned about Darcy permeability with this test, then you can ignore that. You also have the specific bubble point fluid. This is the wetting agent that you use to initially soak your sample. This machine, like I said, uses two different liquids. One of them is an agent that you pre-wet the sample with. The second one is a liquid that goes on top of the sample when the test is running. As pressure increases, the liquid pressure increases and eventually starts to push the wetting liquid out of the pores. By pushing the wetting liquid out of the pores, you now get flow through the membrane itself. This is what occurs as you pressurize the sample. More and more of those pores are being evacuated of the wetting agent and now allow flow. So you get more flow as you go along. This is critical for the test, is the interfacial tension between the two liquids. This is a known value that you have to make sure is calculated correctly, or it throws off all your pore size diameters. So, in terms of membranes, if you know that a specific tortuosity of your membrane, you can input it as user-defined. However, we have also the default of 0.715, which is a rough average of most tortuosity factors of an unknown substance. Here you put the test fluid name and its fluid density, which are critical for the calculations on the scale for how much flow is going through and everything like that. Here you can put a specific data location save for the file and everything. You just hit select and then you can go off into whatever area you want to save your file, so you can create nice special folders. This is the edit test parameter screen. So by clicking here, it brings you up a wide variety of different parameters. If you click on any single one of them, it gives you a description of what it does and the units that is in. The key things that we'll cover here is fill time. So this is how long you let the fill pump actually run for. The fill pumps we have in these machines are designed for about 17 milliliters of liquid a minute. So if you know you want roughly 20 in there, you can factor this accordingly. Other thing is, like I was saying with the scale, you have a maximum test volume change. If the scale ever exceeds this value that you input, the test ends right there. It's another check on the system so that you end the test roughly when all the liquid is out, rather than just waiting for it to go up to whatever pressure. The other way to end the test is this end pressure. So you can change the beginning pressure and the end pressure of the test to whatever you need to cover for your specific sample. Key thing is the incremental pressure. So this influences how many points of data you will actually receive, because it allows for you to, so you can record points every 5 psi if you're running a long test, every 10 if you want it to go a little quicker, or if you're running something from like 0 to 10, you can go by half a psi unit, and this will ramp up the pressure to those units. So the only other thing you have to worry about is compression pressure. So this piston, the compression pressure has to be higher than whatever you're running the sample to. If it's not higher than that, then you will run into serious problems when you're running the test. So, for the purpose of the test we're about to run, we're going to hit Start Test. So once you have hit Start Test, it will first say, bring you up double check to make sure the sample is loaded, which it is. And then the test initiates. First thing it does is it zeroes pressure gauges, and it ramps up the compression pressure so that the piston will come down. The piston has to be the first thing that comes down because the liquid is passed through the middle of the piston. If you put liquid on after the piston comes down, you can artificially press liquid out of the sample, and you don't want to do this. So once the piston goes down, Then, liquid is pulled from the reservoir into the chamber. And then the test proceeds.